In this video, I'm going to be going over the general strategy for solving an optimization problem. Now, you have to keep in mind, with optimization problems, they are all different. But even though that they are different, there are certain common things that we want to look for. And the first thing is to identify the objective function. The objective function is the function that you want to optimize. So in this first example down below, it says maximize p equals 16xy. That, therefore, is our objective function. Okay, that is what we want to maximize or possibly minimize. If we have a revenue function, quite often we will want to maximize revenue. We will want to minimize our costs. Now, if the function has two independent variables, we need a constraint. And so this does have two independent variables. It has an x and a y, where p, whatever p stands for, maybe profit, is the dependent variable, but x and y are the independent variables. In other words, we have two variables over here in the rule of the function. When that occurs, we need to find a constraint equation. And so the constraint equation in this case is x plus y equals 6. Now the constraint equation will always be the equation that relates the variables in the objective function. So you'll notice that the variables in the objective function are x and y, and the constraint tells us how x and y are related to each other. X plus y is equal to 6. So we have now identified the objective function, and we have identified the constraint. Well, the next thing to do is to substitute the constraint equation into the objective function. This will eliminate the extra variable. And so let's do that. We want to take p equals 16xy, and let's get rid of the y. So what I'm going to do with x plus y equals 6, the constraint, is solve it for y. And I get y is equal to 6 minus x. I'm then going to substitute in 6 minus x for the y. So you can see what I did, just some basic substitution. Got rid of the y by taking what y was equal to. Y, of course, is equal to 6 minus x, so I substituted that in. And now let's clean this up a little bit. 16x times 6 is 96x minus 16x squared. So this is now step 3. Step 3 was where we substituted the constraint into the objective function. You'll notice that none of this involves calculus. All of the calculus actually comes in the last step. So in the last step, we need to, as it states here, optimize the objective function. Use the procedure for finding extrema that we learned in another lesson, and then determine if the extrema are max or mins using the second derivative test. So we want to find the extrema. So remember that the extrema, or the critical values, are where the first derivative is equal to 0 or undefined. So let's find the first derivative, p prime. First derivative would be 96 minus 32x. Well, to find the critical points, we set this equal to 0. And so we get 96 equals 32x, or x equals 3. You'll also notice that there is no place where f prime of x is undefined. Doesn't exist, so we don't have to worry about that. So this is our critical point. This is the critical point, or the critical value, which will give us our extrema. Now, what we need to do is determine if x equals 3 is a maximum or a minimum, because what we're looking to do here is maximize, which means this is only our answer if it's a maximum value. So this is where we go to the second derivative test. The second derivative test says we find the second derivative of our objective function. So here's p prime. We want to find the derivative of that, which is simply negative 32. So what we learned in a previous lesson is that if this is constant and it's always negative, okay, it's always negative. So p double prime is always less than 0. That means that this is always going to be concave down, which means that we have a relative maximum. So the point is a relative max, which is what we're looking for. So you're wondering why we were spending so much time looking for relative maximums and relative minimums. It's for optimization problems. All right, so what can we conclude here now? We can conclude that x equals 3 will maximize p equals 16xy. X equals 3 is the value that will maximize p equals 16xy. And that is what we are looking for with a maximization problem. So make sure that you understand these 4 steps. And you won't always have a constraint equation. Sometimes you will, sometimes you will not. So make sure that you understand how to tell if your objective function will require a constraint or not.